In this proof by deduction question, we are asked to prove that the sum of the squares of any three consecutive positive integers cannot be divided by 3. That is a mouthful to say, so let's see how we're going to prove it. In a question like this, my preferred method is to work backwards. It's complicated to think about the sum of the squares of any three consecutive positive integers. But if we work backwards, we can actually construct it from the base up. So rather than considering from the start, let's consider the end. We can think about what is a consecutive integer and 3 of them all in one go. What does that mean? So any integer, I'll choose n, for example. You could choose a different letter. The next integer after that on the number line is n plus 1, and the next one after that is n plus 2. So these are our 3 consecutive integers. If we want to consider their squares, we can simply square them, each individually. So we're going to get n squared, n plus 1 squared, and n plus 2 squared. So this is the squares of any 3 consecutive integers. Finally, the sum is just a math word for add. So we can add together those 3 expressions. And what we're going to get, once we expand and simplify, is an expression for the sum of the squares of any 3 consecutive integers. I think I've said that a few too many times now. If we add together the n squareds, we get 3n squared. If we add together the n terms, we get 6n. And the 1 and 4 are going to give us 5. Because the question is talking about being divided by 3, taking out a factor of 3 feels appropriate here. It's easy for the n squared and for the n term. What I'm going to do with the 5 is I'm going to split it apart into 3 and a 2. So 3 times 1 in the bracket, and then a 2 on the outside. That's going to be helpful to prove the actual question, because if it's written as 3 times something in a bracket plus 2, that means that the remainder, when this expression is divided by 3, the remainder is going to be 2. So in words, the sum of the squares of any 3 consecutive integers will leave a remainder of 2 when divided by 3. I'm then going to copy out the original question just to say, therefore, if it leaves a remainder of 2, then it's not leaving a remainder of 0, which means that it's not got a factor of 3. So I'm just going to rewrite the question to say the sum of the squares of any 3 consecutive positive integers cannot be divided by 3. And that will get us our full 3 marks.